Hi everyone. Today I'm talking about the Internet of Things and a cool messaging protocol called MQTT. But first I have to say thanks to Rod for the awesome theme for the slides. So, okay, so let's start. So guys, how many of you have coded something today? Oh, okay, an applause for all the guys that coded something today. Okay. I hope even somebody has released an npm module today. Let's hope that. But okay. Yeah, okay, Rod did. Perfect. So we code, we do stuff, right? Well, how do we code an app? Because today, what we do, most of us do, is coding applications, right? Basically, we just code some response to some user interaction, like clicking, pitching, zooming, whatever. We build this stuff, right? But this is just a call to our Node server, right? We may do some WebSocket magic, but it's not really changing much in this pattern. We submit something to our server, open a connection maybe, whatever, and we get something back, and whoo, 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 our application pops up and does stuff, right? Well, how do we code this thing? That's the issue. Does it change something that we are coding this stuff? Well, we want to do our cloud thing. We want to use Node. We want to use the cloud. We want to be able to control the stuff remotely. Well, we have a couple of problems over here. The first one is battery. Come on, guys. How many times do you charge your mobile phone every day? Maybe, oh, well, mine stays plugged all the day, I think. Okay? Well, that's the main issue. Then the second thing is that, well, we want to have something in our house, right? Build some cool Internet of Things application. Well, that's it. It sits behind a firewall. It sits behind our router. Yeah. Maybe a problem if you want to send a message directly to it, right? It should be fast. Should react to real world fast. You tap and do stuff. We need some kind of scalable solution for this problem. Because, come on, I've seen the latest prediction about the Internet of Things. It's 80 billion stuff connected to the internet by 2020. How many of you are running a service with 80 billion persistent connections in it? Okay. Well, I'm talking about MQTT today, which is a very nice protocol. It's 20 years old. So why the hell I'm talking as a new stuff? Well, we'll see. MQTT was born in an era where we got like a few bits per second. So it's extremely optimized for low overhead, almost no overhead, okay? So it's a publish-subscribe thing. There's a central broker, it's a centralized thing, and somebody listens to some events, and someone else publish stuff, right? It's kind of a distributed event emitter thing, which you all knew perfectly, right? Does anybody doesn't know anything about events here? Okay, so nobody. Okay, MQTT as first thing is binary. Most of the packets has a 2 bytes overhead, which is fucking small, actually. It's publish-subscribe. Well, it has 3 levels of quality of services. We will see one later. The one is not really even used a lot, and it's standard. It means standardized, actually, but it will be standard in a few months. Well, that's it. It has a very cool feature, which I think is the best one. It has an offline mode, which means that when you subscribe, you will get, and then you disconnect because it's your own mobile or whatever. Then, well, when you reconnect, you get all the package left. So let's move to some code. First, we have an MQTT.js library on npm, right? Cool! And it's fast. And well, it's based on streams and at a high level client API. I'm one of the maintainers. So instant gratification. What does this code does? Well, it creates a client, and it subscribes to one single endpoint, node.conf/eu, and it listens for some messages, and then we publish. Okay? So we can run this thing, pop up. Okay? Let's do something more. Mosquito is a tool for doing this, for interacting with. It's a broker, and it also provides some command line tool for interacting with MQTT Broker. So node.conf/eu. Okay, let's run this thing again. This works, but also it's in here, right? And it can be run also in your Arduino, in your Raspberry Pi, wherever. It's totally real time. Okay, so let's continue. Well, this stuff running inside the browser. Why the hell? It's a protocol for the Internet of Things. It can run on streams, so you can run it directly on top on Engine.io, WebSockets, whatever you want, and thank for Substack for Browserify. Nothing will be possible without this. It's based on unreleased code, so take it with a grain of salt. It works, as you've seen, but okay. So what I've done is this broker called Mosca, which means fly in Italian, and it can be used standalone. Is what I'm using for these demos, but it can also be embedded in your app, like Level Up, LevelDB. Okay, you can build your own broker and add your own functionality to it for making scalable Internet of Things application. So it has some authentication API, which I know some cool guys are doing some stuff all over the world. And it can be plugged on top of any known pub sub system. To support the databases, to support the persistent offline mode, we need also a database. And well, I am one of the Level Up committer because I've started using Level Up for this. And actually, that's it. We need a database, okay? Because the persistent for the offline mode. Yeah, so part of the socket. There's a pull request out there. So it's fast. How fast it is? Well, I've run two processes for this benchmark. One opened 5,000 connections to my broker, and the other was the broker on this MacBook. So this was the latency of receiving one packet. So you will see 350 milliseconds for getting, in this scale, pretty linearly, okay? So the cool thing is the offline mode, which actually is something that I really love. So what does this example do? First, we specify two stuff. First is the client ID. We need a unique identifier for our client, okay? Because we want to receive the message when we are offline. Okay, like in this conference, maybe Wi-Fi access is not really okay, and maybe you are offline, but you want to receive the messages that were sent where you were here. And well, this is a client ID, and this also flag also clean false. That's just that. Triggers on the offline capabilities. So first we subscribe, and look, we pass this thing called QoS1. We just set the quality of service level. We can't have quality offline mode for quality of service 0 because there's no guarantee of success, right? Quality of service 0 means nothing. Message is sent, who knows if we will receive it at all. However, with quality of service 1, we can guarantee that we receive at least one time each packet. And the third one is a callback for, well, the subscribe is done. So we can run this thing, and okay, subscribe done, right? But, well, we can then run a message. This is just very similar to the others. However, we just do a publish, and this publish is with quality of service 1, 2. Okay? And publish done. Then we can do maybe a publish from this thing. Oh, well, can't remember the syntax. I'm sorry, guys. And we can run this, the offline mode, and we get our message, right? Node.conf EU offline LOV Vikings, okay? Because look, you don't even do the subscribe over here, right? We just reconnect, and we get the session at the very exact point where we got it before disconnecting. And we get all our messages back. This is cool, yes. It also works in the browser, so if you disconnect, you automatically get all the updates again. Okay? Well, that's the scale. Mosquito is a C++ broker, and this is my Mosca thing. And this graph just tells you what. Take a little bit your conclusion. Kind of, Mosca can handle the publish subscribe thing pretty well, and also the offline pattern pretty well. I have to thank Level Up for this, mainly this guy, come on. Yeah, because it wouldn't really be possible because this thing is on LevelDB, and well, it's pretty fast.
That's time on the left, right?
On the left is time, and on the right is a number of packets.
So Node is faster and no leaks.
What?
Node is faster because it's lower, right?
Yeah, actually Node is faster because it's not just Node that's fast. Is that you can do crazy stuff with Node much more easily than in anything else. And we get some clever algorithm by some contributors out there that can actually allow this to be extremely fast. So I'm just adding a little couple of stuff. There is a project called Ponti, which is a bridge, actually, for the Internet of Things. You actually want to expose your stuff to the web, and also not only interact with MQTT, but also with other protocols. There is this one called COAP, Co-op, which is based on UDP, and that's there. It will be part of the Eclipse Foundation soon. We will have a Node.js project inside the Eclipse Foundation. So I don't know. It's very nice because what the Eclipse Foundation is doing is very hot on the machine-to-machine phase, and it's a cool way for getting new people on board in this. Well, I have another demo, which is I couldn't really bring my hardware with me. That's kind of unfortunate. However, well, if it works, okay. I have a little LED running in Italy that I can control remotely from here. Okay, so let's see what it is. I have this and take it from here. Okay. Do you guys know about Tweetbot? Well, it's a very nice interface for Twitter. It's kind of pricey, but okay. I can control it from Twitter. And well, take some time. And I can also control it from my iMessage. Okay, this is the same thing from I can access from Twitter. And yeah, where it is? Come on, over here. Yeah, I turned it off. If you want to turn on and off my LED, you can try. You can tweet this tweetbot. Is called. You can control it like this, and turn light on or off or whatever. So have fun.
Enslave the human race.
Yeah! Let's build Skynet. And where it is. Okay, sorry guys. Here we go. And well, thank you.